All right, so another way of showing an algorithm, or another example we use here, is directions from get to point A to point B. All right, Google has this really great maps tool. If you haven't used it, I encourage you to check it out. Just at maps.google.com, and I'm going to try and get directions. And what I'm going to do is, boy, I got a meeting maybe later in the week here, and I need to find how to get there. And I'll ask for directions from Google. And I'm going to go from the Missoula College, or the College of Technology, Missoula. I'll just put that in. And it'll give me actually a series. Well, it says, here we go, College of Technology, Missoula. And I'll say, yep, that's what I'm looking for. And here's all the different listings for that. And I'm going to choose, ours is at 909 South Avenue West, so I'll choose that. That gives me a starting point, and here I have a graphical representation of it. Okay, it's not a flow chart, but in this case it's a map. And I have a meeting out at Blackfoot Communications, and they're up on North Russell, so I'll click there and I'll say, give me directions. And Google does a nice job with this, and down in the lower part here it gives me actually written instructions on how to get there, and even gives me a time estimate. Okay, it's going to be about 11 minutes. It's 3.6 miles, and here's the directions that it recommends. Now it also has some other recommendations for instructions to get there. So one of the points with algorithms is two algorithms can have the same result. All right, so I could take the Stevens Avenue West Broadway, or I can go out Russell, and actually it's the same amount of time, 11 minutes, but it's a little bit shorter. Okay, that actually saves me 0.7 of a mile. All right, and then the directions changed with that. So it's really kind of a great tool to use. Let me show you one other little variation of it here. Across the top here, I'm assuming I'm going to drive, but I could also bus, and that's going to give me a whole different set of instructions here. So I'll see the bus route here, and here it is, 44 minutes that direction. That doesn't seem so good. Let me take this, there's multiple paths to get there. Here's one that's 33 minutes. That's still a long time, but let's check that one out. And that one seems like it takes me quite a different way as well. But let me try and walk. Maybe it's faster for me to walk. 52 minutes to walk, but see, I take a different route there. All right, let's show one more example here. I'm going to bike, kind of combination, because it's just not reasonable to get there by bus. And what we got here, I guess we're still loading here. Okay, I had to pause for a second there. My internet connection dropped for just a brief minute, but here's my bicycling instructions, and this seems like it's a little more reasonable. My car route was 11 minutes on a bike. It'll take me 19 minutes, but there's a significantly different route that way because I head out the same direction, but there's this bike path, and it's the old railroad grade, and you can follow that down, and it takes you across a different bridge rather than Russell Street Bridge, the California Street Bridge. And then from there you can get back on North Russell, so it's much more pleasant for bikers. 19 minutes. Okay, so these are all examples, and here's the biking directions. And these are all examples of algorithms, and with the neat tool that Google has put together here, we can see it as a graphical representation and also as a natural language.